Today we start a new chapter, probability. In this chapter we cover 4 sections. First is conditional probability, second is independent event, third is Bayes theorem, and fourth is probability distribution. CBS deleted some portion from this chapter, that is binomial distribution, mean and variance are deleted. In our board exam, from this chapter we get 1 mark question, 2 mark question and 5 mark question also. So try to practice all the questions of our NCERT test. Also do some extra questions using any other North Indian test such as Shardi Sharma or any other. Okay, if you have any doubt, please clarify it through my WhatsApp. Okay, now we start the class. In this chapter, last section, CBS did small portions, but majority of the portions are included for the exam. First of all, we remind some portion from our first year classes. What is random experiment? An experiment in which the outcome cannot be predicted is called a random experiment. An experiment in which the outcome cannot be predicted is called a random experiment. For example, coin tossing experiment, die throwing experiment, and a ball is drawn. Different color of balls are in a box, and we take a ball. Which color is to be selected is cannot be predicted. Such type problems, such type experiments are called random experiment. Now outcome, possible result of a random experiment is called outcome. Suppose you take suppose you tossing a coin, and possible outcomes are head or tail, and a die is thrown. Possible outcomes are the numbers 1, 2, 3, 4, 5, 6. Then what is sample space? Possible outcomes of a random experiment is called sample space. ഈ കിട്ടുന്ന റിസൾട്ട് എല്ലാം ഒരു കണ്ടെയ്ൻ ചെയ്ത് ഒരു സെറ്റ് ഫോം ചെയ്ത് ദാറ്റ് ഈസ് കോൾഡ് സാമ്പിൾ സ്പേസ്. പോസിബിൾ ഔട്ട്കംസ് ഓഫ് റാൻഡം എക്സ്പെരിമെൻറ്റ് ഈസ് കോൾഡ് സാമ്പിൾ സ്പേസ്. Then what is an event? Event means subset of a sample space is called an event. Subset of a sample space is called an event. Suppose a die is thrown and possible outcomes are 1, 2, 3, 4, 5, 6. Suppose you take an event, even numbers appearing is considered as an event. Then the possible outcomes are A is equal to, we get a 2, 4, 6, and odd number considered as another event. Then suppose you take B and B is equal to, we get answer 1, 3, 5. These are all events. Shortly we define as a subset of a sample space is called an event. And last you define what is probability of an event. Probability of an event means number of elements of that event divided by the total number of elements of the sample space. N of A divided by N of S, that is called a probability of an event. Probability of an event means N of A divided by N of S, where A implies event and S implies sample space. Also we define a definition of mutually exclusive and exhaustive events. What is mutually exclusive? Two events are said to be mutually exclusive. Our condition is if A intersection B is equal to 5. And two events A and B are said to be exhaustive events if A union B is equal to S. That means their union is, again we get a sample spaces, that is 2 or more events are considered in the exhaustive case. If 2 or more events are said to be exhaustive, suppose A, B, C, D are 4 events, then A union B union C union D is equal to S, we get then A, B, C, D are called exhaustive events. These two events are said to be mutually exclusive if A intersection B equal to 5, and events A and B are said to be exhaustive if A union B is equal to S. This is a very important point. This is also necessary for the independent event. Now we come to the next second year portion. Here the probability comes 5 sections. Our first is conditional probability, second is independent event, third is Bayes theorem, fourth is probability distribution, and last is binomial distribution or Bernoulli status and binomial distribution. Here some portions are deleted, majority of the portions are included in this chapter. Our first definition is conditional probability. What is conditional probability? Here I take a sample space. When two coins are tossed, the possible outcomes of the sample space, head, 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 tail, tail, head, and tail, tail. And we consider two events. Subset of the sample spaces is called an event. Here I consider two events. First event is two head or two tail turns up. That is we consider as the first event. Two head or two tail turns up. Therefore, the possible outcomes are head, head, and tail, tail. Two head or two tail consider as the first event. Then second event is at least one tail turns up. At least one means one or more. At least means one or more. One tail or two more. Two tail is considered. Here one tail elements are head tail, tail head, and TT also. That means the second event elements are HT, TH, and TT. Because the event says that at least one tail. Here we consider two events A and B. Actually, conditional probability says that find the first event, find the probability of the first event using the second event. That means we find probability of A given B. That is a conditional probability. That means we find two head or two tail, find the probability of getting two head or two tail from the second event. That is the probability A given B condition says. ഫസ്റ്റ് ഇവൻറ്റ് പറയുന്നത് രണ്ട് ഹെഡ് ഓർ രണ്ട് ടെയിൽ വരുന്നതാണ് ഫസ്റ്റ് ഇവൻ്റായിട്ട് പറയുന്നത്. സെക്കൻഡ് ഇവൻറ്റ് പറയുന്നത് അറ്റ്ലീസ്റ്റ് വൺ ടെയിൽ, വൺ ഓർ മോർ ടെയിൽ വരുന്നതിന് നമ്മൾ ബി എന്നുള്ള ഇവൻ്റായിട്ട് കൺസിഡർ ചെയ്ത്. കണ്ടീഷണൽ പ്രോബബിലിറ്റി ഡെഫിനിഷൻ പറയുന്നത് ഒരു ഇവൻറ്റിൻ്റെ പ്രോബബിലിറ്റി നമ്മൾ മറ്റൊരു ഇവൻറ്റിൽ നിന്ന് കണ്ടുപിടിക്കുക. ദാറ്റ് ഇസ് എ കണ്ടീഷണൽ പ്രോബബിലിറ്റി. എ എന്നുള്ള ഇവൻറ്റിൻ്റെ പ്രോബബിലിറ്റി സെക്കൻഡ് ഇവൻറ്റിൽ നിന്ന് കണ്ടുപിടിക്കുക. ഈസിലി വി ഫൈൻഡ്. ഫസ്റ്റ് ഇവൻറ്റ് പറയുന്നത് എന്താണ്? ടു ഹെഡ് ഓർ ടു ടെയിൽ. ഈ ഇവിടെ നിന്ന് കണ്ടുപിടിക്കുക. ടു ഹെഡ് ഓർ ടു ടെയിൽ വരുന്ന ഒരൊറ്റ എലമെൻറ്റേ ഉള്ളൂ, 1 ഡിവൈഡ് ബൈ ടോട്ടൽ ഔട്ട്കം 3. ദാറ്റ് ഇസ് ദ കറക്റ്റ് ആൻസർ. ദാറ്റ് ഇസ് പ്രോബബിലിറ്റി എ ഗിവൺ ബി. ആൻസർ ഈസ് 1/3. ഇറ്റ്സ് വെരി സിമ്പിൾ. ബട്ട് നമുക്ക് എല്ലായിടും ഈ ഒരു കോൺസെപ്റ്റ് യൂസ് ചെയ്ത് കഴിയുക ഇത്തിരി ഡിഫിക്കൽട്ടാണ്. സോ ഹിയർ വി ഡെവലപ്പ് എ ഫോർമുല. ദാറ്റ് ഈസ് സപ്പോസ് ഇ ആൻഡ് എഫ് ആർ ടു ഇവൻറ്റ്സ് അസോസിയേറ്റ് വിത്ത് ദ സാമ്പിൾ സ്പേസ് എസ്. Our definition is very important. Suppose E and S are two sample space associated with the sample. E and F are two events associated with the sample spaces. If E and F are two events associated with a sample space S, then probability of E given F is equal to, our definition says that P of E intersection F divided by P of F. That's called conditional probability definition. That's all. We will do some problems using this formula. Our first question is P of E is equal to 0.6. P of E is equal to 0.6. P of F is equal to 0.3. P of E intersection F is equal to 0.2. Find P of E given F and P of F given E. Okay. You know the formula P of E given F. Using the definition we know P of E given F is equal to P of E intersection F divided by P of F. Here P of E intersection F is already given 0.2 divided by P of F is 0.3 is equal to, we get answer 2 divided by 3. Similarly, P of F given E, using this definition, we say that P of E intersection of divided by on a given event is E, that is divided by P of E. That is equal to 0.2 divided by 0.6 is equal to, we get answer 1/3. Okay, using this formula, we can easily find the probability of the conditional probability of the event. Now, discuss one more question. Evaluate P of E A union B. evaluate P of A union B. Given 2 into P of A is equal to P of B is equal to 5 divided by 13. Also given P of A given B is equal to 2 divided by 5. Okay, here given condition is 2 into P of A is equal to P of B is equal to 5 divided by 13. And therefore P of A is equal to, we get answer 5 divided by 26, and P of B is equal to same answer 5 by 13. For finding P of A union B, already you know what is P of A union B, we discussed in our first year classes. You know P of A union B is equal to P of A plus P of B minus P of A intersection B. So here now we find P of A intersection B using the conditional probability. You know the definition is P of A given B is equal to B given 2 by 5. What is P of A given B? P of A intersection B divided by P of B is already given 2 divided by 5. That implies P of A intersection B divided by what is P of B, that is 5 by 13 is equal to 2 divided by 5. Here 5 cancel, and therefore P of A intersection B is equal to, we get answer 2 divided by 13. 2 by 13. Now using this condition we find P of A union B. You know P of A union B formula is P of A plus P of B minus P of A intersection B. Here P of A is equal to 5 divided by 26. What is P of B? That is 5 divided by 13. And what is P of A intersection B? 2 divided by 13. That is equal to 5 by 26 plus 10 by 26 minus 4 by 26. Here the common denominator is 26 and numerator we get answer 15 minus 4, answer is 11 by 26. That's all. Okay, now we'll discuss one more question using the definition of conditional probability. A coin is tossed 3 times. If you have any doubt in the question, please refer NCERT test exercise 13.1, question number 6. Question number 6. The question is, a coin toss 3 times, where E denote head on third tosses, where E denote head on third tosses, head on third toss, E denote head on third toss, and F denote the event that head on first 2 tosses, head on first 2 tosses. Find P of E given F. Find P of E given F. Okay, you know when a coin is tossed 3 times, the possible outcomes are head, 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 H, H, T, H, T, H, T, H, 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 T, 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 H, T, 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 H, and last T, T, T. That is total elements are 1, 2, 3, 4, 5, 6, 7, 8. Totally contain 8 elements. Now the first event, the required event E, head on third tosses. Therefore the elements are head, 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 then H, T, H. So third toss is contain H, then T, H, H, and last T, T, H. There exist 4 elements. Then F, here what is F? Head on first 2 tosses, that is H, 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 then H, H, T. That's all. For finding conditional probability, next we find E intersection F. There exists only one element which is common to both E and F. Now, what is P of E? Which contains 4 elements. 4 divided by total outcome is 8 is equal to 1 by 2. P of F. What is P of F? F contains 2 elements, 2 divided by 8. And P of E intersection F. is equal to 1 divided by 8. Using definition, you know P of E given F is equal to P of E intersection F divided by P of F. That is P of E intersection F is 1 by 8 divided by what is P of F? That is 2 by 8 is equal to, we get answer 1 by 2. That's all. Directly ആയിട്ട് നമുക്ക് കണ്ടുപിടിക്കാൻ പറ്റും. ഇപ്പോൾ ഫസ്റ്റ് മീൻസ് ഹെഡ് ഓൺ തേർഡ് ടോസസ്, അത് നമ്മൾ സെക്കൻഡ് ഇവൻ്റായ ഹെഡ് ഓൺ ഫസ്റ്റ് ടു ടോസസിന് കണ്ടുപിടിക്കുക ഡയറക്റ്റായിട്ട്. ദാറ്റ് ഇസ് എ കണ്ടീഷണൽ പ്രോബിലിറ്റി. ഹെഡ് ഓൺ തേർഡ് ടോസ് ഈ പറഞ്ഞ സെക്കൻഡ് ഇവൻറ്റിൽ എത്ര എലമെൻറ്റ്സിലുണ്ട്? ആ ഒറ്റ എലമെൻറ്റ്സേ ഉള്ളൂ. 1 ഡിവൈഡ് ബൈ ടോട്ടൽ എലമെൻറ്റ് എഫ് കണ്ടെയ്ൻ 2 എലമെൻറ്റ്, ദാറ്റ് ഇസ് 1 by 2. ദാറ്റ്സ് ഓൾ ആൻസർ. ബട്ട് ഡയറക്റ്റായിട്ട് കണ്ടുപിടിച്ചാൽ നമുക്ക് മാർക്ക് വലിയ കുറയും. സോ യൂസ് ദിസ് മെയിൻ സ്റ്റെപ്സ്. Our next question, question number 9, 13.1 exercise question number 9, 13.1 exercise question number 9. Mother, father and son line up at random for a family picture. Mother, father and son line up at a family picture. Therefore, the sample space contain mother, father and son, M, F and S. Line up ആയിട്ട് നമ്മൾ ഫോം ചെയ്യുമ്പോൾ MFS ഫോം ചെയ്യാം. Then MSFI ഫോം ചെയ്യാം. Then SFM, SMF. Then FMS and FSM. ഈ ഇത്രയും രീതിയിൽ നമുക്ക് ഇതിനെ അറേഞ്ച് ചെയ്യാൻ പറ്റും. ദ പോസിബിൾ ഔട്ട്കംസ് ആർ MFS, MSF, SFM, SMF, FMS ആൻഡ് ലാസ്റ്റ് FSM. ഓക്കെ, മദർ, ഫാദർ ആൻഡ് സൺ. അപ്പോൾ ലൈനപ്പായി കിട്ടിക്കഴിഞ്ഞാൽ ഈ ഇത്രയും രീതിയിൽ നമുക്ക് അറേഞ്ച് ചെയ്യാം. നൗ ദ ഫസ്റ്റ് ഇവൻറ്റ് ഈസ് സൺ ഓൺ വൺ എൻഡ്. അപ്പോൾ ഫസ്റ്റ് ഇവൻറ്റ് E ഈസ് സൺ ഓൺ വൺ എൻഡ്. Sun on one end means the elements which contain sun on one end are MFS, sun is on one end, then SFM, SMF and FMFS, SFMS. Three elements like sun on one end. Now the second event, F, father in middle. Father in middle, the elements which contain father in middle, MFS, SFM. That's all. These two elements contain father in middle. Now E intersection F, that means elements common to these two events are MFS and SFM, MFS and SFM. Now the probability P of E is equal to 1, 2, 3, 4. 4 divided by total outcome 1, 2, 3, 4, 5, 6. P of F. P of F is equal to 2 element divided by total outcome. And P of E intersection F is also 2 divided by total outcome. And therefore using conditional probability we find P of E given F. P of E given F is equal to, the definition is P of E intersection F divided by P of F. What is P of E intersection F? 2 divided by 6 divided by P of F is also 2 by 6, and therefore the probability is 1. You know this, which is the maximum probability. You already know maximum probability of element. The answer is 1. It's the maximum probability. Now we'll discuss one more question using the concept of conditional probability. Our next question is question number 13. Question number 12. Sorry. Question number 12. Question number 12. Same exercise 13.1. 13.1. If you have any doubt in the question, please refer the answer test. Question number 12 says that assume that each born child is equally likely to be a boy or a girl. If a family has 2 children, what is the conditional probability that both are girls, given that the young is a girl? And second question, at least one is a girl. Okay, Here the sample space contain the elements are, assume that each born child is equally likely to be a boy or girl if a family has two children. For the possible elements are a boy or a girl. If a family has two children, what is the conditional probability that both are girls given that the youngest is a girl? At least one is a girl. Therefore, the possible elements are two are boys or two are girls or one boy or one girl. Okay, that is, suppose we consider the first element is B. Here capital B represents elder and younger B. Then second is BG. Okay, BG. Third is GB or GG. Here capital representation implies is a elder, and second small represent younger. Okay. Here capital B represent elder boy. Capital G represent elder girl. Small b represent younger boy, and small g represent younger girl. Okay, using this concept, the possible outcomes are BB, BG, GB and GG. Okay, now the first event E. What is E? Event E says that our first question is find the conditional probability that both are girls. Here the both are girls means the elements both are girls is G, only G, comma G. And second event, or first question, second event, the youngest is a girl. The youngest is a girl means second element is a girl. The elements are B, G, G. Now, E intersection F is equal to G, G, and therefore probability of E given F is equal to, using definition we say that P of E intersection F divided by P of F, that is equal to, what is the probability of E? Here probability of E is equal to 1 divided by 4. Probability of F is equal to 2 divided by 4, and P of E intersection F is also 1 by 4, and therefore P of E intersection of answer is 1 by 4 divided by 2 divided by 4, answer is 1 divided by 2 is the first question answer. Now for the second question, E is same G, small g, and F, what is F? Our second question says that at least one is a girl. Find the condition for probability that both are girls given that at least one is a girl. Second event is at least one is a girl means one or more girls is considered. At least one is a girl means one or more girl is considered. That is, we consider BG, GB and GG. And therefore E intersection F is equal to, same answer we get small capital G, small g, and therefore P of E, here what is P of E, is equal to 1 divided by 4. P of F is equal to 3 divided by 4. P of E intersection F is also, we get answer 1 by 4, and therefore P of E given F is equal to, definition, P of E intersection F divided by P of F, that is equal to 1 by 4 divided by, what is P of F? P of F is 3 divided by 4 is equal to, we get answer 1 by 3. That's all. It's a very simple question. I will discuss one more question. Question number 13. Same exercise. Question number 13. 13.1 exercise. 13.1 exercise. Question number 13. An instructor has a question bank consist of 300 easy true false question, 200 difficult true false question, 500 easy multiple choice question and 400 difficult multiple choice question. If a question is selected at random from the question bank, what is the probability that it will be easy question? Given that it is a multiple choice, we find the probability that it will be an easy question. Easy question probability given event is a multiple choice question. Here, using the given condition, we form a table. Using the given condition, first of all, we form a table. Okay, easy, difficulty. Difficulty, easy, difficulty question and total question. Easy, difficulty and total question. Then true, false question. True, false question. Second is MCQ questions. MCQ. Third is also total. Here easy 300 true false question, 300 true false question, 200 difficult true false question, total is 500. Then MCQ 500 MCQ question, easy question, 400 difficult MC question and total is 900. Here also total easy question is 800, total difficulty question is 600 and grand total is 1400 questions. Here given conditions are built up in a table. Now, you know the total number of elements of the sample space is 1400. Here n of s is equal to 1400. And now E, what is E? E implies getting easy questions. Easy questions implies the event E. And F implies, what is F? Given condition. What is F? Given that is a multiple choice question. MCQ questions. Okay. MCQ questions. MCQ questions are in the second event F. Now P of E. What is P of E? That means easy question. Here total here contain 800 easy question divided by total is 1400. Then P of F. What is P of F? MCQ. Total MCQ is 900 divided by 1400. Then P of E intersection F. What is P of E intersection F? That is EC and MCQ. EC and MCQ common. EC common MCQ. EC MCQ common is 500. 500 divided by 1400. And therefore now we find P of E given F. Find P of E given F. Using conditional probability definition, it says that P of E given F is equal to P of E intersection F divided by P of F is equal to, you know, P intersection F is 500 divided by 1400, the whole divided by P of F 900 divided by 1400. Here 1400 cancel and therefore we get answer 5 divided by 9. That's all. It's also a very simple question. Okay. These are the main questions based on conditional probability. Now we'll discuss some special problems regarding the topic conditional probability. That will be discussed on next video.